All right, so here's our next video. So in order to have this one make sense, you would have needed to watch the accuracy video and the precision video. What we're going to look at in this one is the rules that go when we add and subtract measurements and the rules for when we multiply and divide measurements. So we're going to tackle the ones up top here, adding and subtracting. Rule number one is the units must be the same. They have to be in the same unit of measure. So you may have to do some conversions. If you are trying to add 25 centimeters to 38 millimeters, you either have to convert the centimeters into millimeters or the millimeters into centimeters. It doesn't necessarily matter which one you convert it into, but they have to be in identical units before you can continue. Okay, the next thing is you add and subtract the digits. So let's say we were going to add 25 centimeters to 38 millimeters. I'm going to change them into millimeters since I already did that here. So to get from centimeters to millimeters, I need to move my decimal one spot to the right, so that ends up being 250 millimeters. So I would take my 250 millimeters, add it to my 38 millimeters, and I'm going to add the digits just like you would normally add them. Okay, so I would have 288 millimeters. Now it says to round to the same precision as the least precise original measurement. So what we need to do is we need to come back to our original measurements here that I was adding together. And I need to find the precision of each of those. So the 250, my last significant figure is in the tens position. In the 38, my 8 is in the ones position. So the 250 has a precision to the nearest tens. The 38 has a precision to the nearest ones. Now notice it says we need to use the precision of the least precise. So that would be my tens. And what that means is I need to round my answer to the nearest tens. So I find that same position in my answer, and then I use conventional rounding rules to round it. So this 8 says I bump that up. So I would put my answer in as 290 millimeters. And that would have been rounded to the same precision as the least precise measurement. Okay, and then make sure you put your label on there. Okay, let's say I wanted to do another one. How about, let's do 48.3 yards, and we want to add 15.275 yards. So this time I don't have to do any conversions because they're in the same units. I can go ahead and add my digits together. And I get 63.575 yards. Now I need to round to the same precision as the least precise original measurement. So in my 48.3, the 3 is my last significant digit, and that is to the tenths position. In the 15.275, this 5 here is my last significant digit, and that is in the thousandths position. So the least precise is to the tenths. So I need to come into my answer and find the tenths position and then round using conventional rounding rules. So 7 says to bump that up, so it would become a 6, and I would end up with 63.6, and then make sure I add on my label. So those are your rules for when you add, same rules for when you subtract. Now, for multiplication and division, we have a different set of rules. Notice there is no requirement that the units have to be the same. Okay, you can multiply and divide essentially any units. So you're going to start just by actually doing the multiplication or the division. So let's say we had 18.3 kilograms times 22 meters per second squared. Okay, and using Newton's second law here, which you don't have to know, but force is equal to mass times acceleration. So I take my mass, I times it by my acceleration. I would type that into my calculator just like normal, multiply them together, and I get 402.6 is what my calculator value is. Now notice for the rounding on this one, it's different. Okay, you round to the same accuracy as the least accurate original measurement. Now remember, accuracy is the number of significant figures. So in my first measurement here, I have 3 significant figures. In my second measurement, I have 2 significant figures. So that means my final answer can only have 2 because I need the least. So I always start on the left side of my number and I mark off 1, 2. So that means I round to this position. I follow my conventional rounding rules. So the 2's say we need to leave this alone. So that would make this 400. Now I would add my label here. So the label will be these values combined. Since it was multiplication, it would be a kilogram times a meter per second squared. But we have a problem on this one. If I leave my answer just like this, it implies there's only 1 significant digit. But I need to indicate that this second one is also significant. So the most common way to do that is to write my answer in scientific notation. Because I need 2 significant figures, I would put it in as 4.0. So now I have my 2 significant digits, and then do 10 times 10 to the second power, and then put in my label of kilograms meters per second squared. There are other ways to indicate that that last digit is significant, but most of the time this is the preferred method that you'll be asked for.